Hi, thanks for joining this session. In this session, we're going to talk about Fargate. And we're going to talk about Fargate, particularly in the context of platform version 1.4 and the features that we announced and deliver with that new platform version. My name is Massimo Referè. I'm a developer advocate in the container team. The way that we're going to lay out this session is we're going to introduce Fargate first at the high level with a couple of demos just to set the stage. And in the second part of the session, we're going to talk more about the features that we introduce with the new platform version, as I mentioned. So let's get started. First of all, what is Fargate? We define Fargate as a serverless compute engine for containers. What does that mean? That means that historically, in order to be able to run containers, you had to have an infrastructure where you would deploy those containers. That infrastructure comprises of a number of virtual machines or EC2 instances that form the capacity in a so-called cluster that allows you to run those containers. With Fargate, you don't need to have that infrastructure at your disposal inside your account. Fargate works with both ECS and EKS. This session is going to be more focused on ECS because that is where platform versions apply. But as a reminder, Fargate can work and does work with both ECS and EKS. Now that we covered what Fargate is, we're going to talk a little bit about why customers like Fargate. There are a number of reasons for which customers like Fargate. I only mention a few of them here. First of all, it's a security discussion. Fargate allows customers to deploy their pod or task with a one-to-one relationship between the task or pod and the virtual machine that is going to run that task or pod. These obviously have good security outcomes. One of the other reasons for which they like Fargate is more related to the operational aspect of running that infrastructure or not running that infrastructure. In fact, with Fargate, you don't have any EC2 instance running in your account to be able to run those containers. So you do not have to manage, patch, scale, deploy that part of the infrastructure to be able to run your containers. This means that Fargate allows you to focus more on the application and what you're building for your own customers rather than having to think about the undifferentiated heavy lifting that are those infrastructure details that I just mentioned. Now that we discussed what Fargate is and why it's useful with those two text slides, I want to show you a visual that kind of represents the difference between an EC2 flow and the Fargate flow. What you see in this slide is the typical EC2 flow. This applies to both ECS and EKS, but I picked ECS in this case. So you have your customer account with a VPC in your account, and you typically have to have the EC2 fleet of instances running in your account to be able to run tasks in this case. So what happens here is that if you ask ECS to run a specific task on an EC2 instance type of infrastructure, in this case, what ECS does is it's going into your account to see which EC2 instance you can use or he can use to run that task. It's going to pick one of those EC2 instances and it's going to deploy that task on that EC2 instance. The task is then going to be connected to your VPC in your account so that that shows up as a first-class citizen in your VPC. As you can see from this slide, there is capacity that is running in your account to support that task, okay, or those many tasks if you are deploying many tasks in your account. There's a big difference between the EC2 workflow and the Fargate workflow because with EC2 you have to manage this capacity, right? That capacity will show up in your account, in your billing, and everything. The Fargate flow is different in the sense that You still have your, obviously, customer account. You have your VPC in your account. But as you can see, you don't have any EC2 instance in your account. The capacity that allows you to run your task, in this case for ECS, is provisioned inside what we call the Fargate fleet. So the workflow is when you ask ECS to run a container or a task, more specifically on Fargate, what we do is we go out into the Fargate fleet, we pick a VM to run that task for you. And we run that task and we connect that task into your VPC. So from a very high level perspective, nothing changes for you in the sense that that task will show up still as a first class citizen in your VPC. But the capacity that is needed to run that task doesn't come from your account. These obviously have a number of positive outcomes in the sense that you don't have to manage any capacity, you don't have to over provision capacity, you don't have to patch that capacity, because that is all basically on us. You're actually just consuming that capacity in a serverless fashion for containers. Let's go a little bit deeper now into the topic of this session, which is platform versions. What are Fargate platform versions? The Fargate platform version represent a combination of OS and container runtime components that we need to have inside that fleet of Fargate instances so that you can deploy your task or pod on that capacity. It represents basically the entire stack that we use to be able for you to do a run of your containers. A new platform version is released when there is a substantial stack change. We will see in a moment that we do not deliver and make available a new platform version for every feature that we release, every Fargate feature that we release. But when there is a substantial change in that stack, we tend to create a new platform version. These obviously have the benefit of avoiding impacting customers with deep changes that we're making in that stack that I was alluding to. And this is particularly true when we have to change OS version or container runtime, so big changes, not just additional incremental features. The other thing that is important to understand is that the notion of Fargate platform versions only apply when using ECS. I'll show you what I mean by that, but basically you're dealing with AWS Fargate platform version only we're deploying through the ECS orchestrator. This is because EKS has the EKS team has their own notion of a platform version, which includes the features that are Fargate related. This is what I was alluding to before. Do all new features require a new platform version? Definitely no. As I said before, new individual features do not require that we build and deliver a new platform version. Those incremental features can be added at a later time to an existing platform version. Actually, a good example of this is we released Fargate platform version 1.4 back in the April timeframe. On May 28th, we made a change to platform version 1.4 so that every new task that has been deployed after that date on platform version 1.4 is encrypted. The ephemeral storage that the task has is encrypted by default. This is an example of an additional incremental feature that we have added on an existing platform version, 1.4 in this case. You should expect us to add more features to 1.4 going forward. This is also a good moment to share that basically there are a couple of features that we add to Fargate platform versions. One that is transparent to the customer, and the encryption of the ephemera storage is a good example of this. This is not something that you opt in or you opt out. When you deploy a new task, every task that you have deployed on platform version 1.4 after May the 28th is encrypted by default. You didn't have to do anything. There are other features that we have added, or we're probably going to add in the future, that require an opt-in or an additional configuration. A good example of this is when we added support for FireLens, which is an advanced mechanism to log inside ECS, and specifically for ECS task. You had to add an additional configuration to your task definition to be able to leverage that feature. So be mindful that there are features that you will consume out of the box transparently, and there are other features that requires you to change some of your task definition configurations. At this point, I wanted to show you Fargate in action. We have been talking about Fargate from a theoretical perspective. Let me show you how it works. So this is the ECS console. Let's start with ECS. I do have a cluster, an existing cluster called my cluster. As you can see, this cluster is running 2 tasks already. You can already imagine that these 2 tasks are running on the Fargate fleet because I don't have any container instance running inside this cluster. So this is also, you can spot this from the list of EC2 instances that I have in my account in this specific region, which is Frankfurt, for this demo. I only have a Cloud9 environment that I will be using for other demos in a second, but there are no EC2 instances. So when you want to run something on Fargate, what you do is the first thing you do is you create a task definition. You can create a task definition with Fargate or EC2 compatibility, depending on where you're going to deploy this to. And then what you're going to do is you're going to add an app name. Let's say my app2, for example. I'm going to attach a task role. Actually, I don't need any task role for this one. And I'm going to assign memory and CPU for this task. This is mandatory because when you create a Fargate or a task definition that you're going to deploy to Fargate, we need to know how big that task is going to be so that we can pick the right instance. The other thing that you would do is you would pick your container that you want to run inside this task. For simplicity, we will just pick Nginx. Obviously, there are a number of additional configuration that you can do, but for the sake of this, I'm just going to do this. So I've created my task definition. I want to go to this task definition here, and I can do a bunch of things here now. What I want to do now is I want to create a new cluster. I want this cluster to be networking only. And I'm going to call this my app2 because I want to dedicate this cluster to my application. Okay, the cluster has been created. I'm not going to add any EC2 capacity here. What I'm going to do is I'm going to take my app here and I'm going to say I want to run this task. So the first thing that I do is I choose Fargate as the launch type. The task definition is already populated. This is where I can pick the platform version that I was alluding to. So when we launch Fargate, we release platform version 1.0.0. As time went by, we added new platform version to Fargate. 1.4 is the last version that we launched, and that has a number of new features that we are going to discuss in the remaining of the presentation. I'm going to pick 1.4. The other thing that I wanted to call out here is that differently from what we have done for the past platform version, when we introduced 1.4, we did not move the latest label. What we typically do when we deliver a new platform version is we move the latest flag to the latest platform version available. In order to mitigate potential risk that customer would incur into by deploying with latest and us changing actually the platform version underneath, we are keeping the latest flag mapped to 1.3 for the time being. We're going very soon to move it to 1.4, but as of today, if you use latest, you're going to pick platform version 1.3. I'm going to pick the VPC that I want to deploy this task into and the subnet. This is my default VPC, and I want to assign a public IP address. Now I'm going to run this task, and what you will see is that this task is being provisioned into platform version 1.4 running on Fargate. You can also see the platform version here. If you open this one and we wait until this is going to be running, that you see here in the status, you can then connect to this IP address and get your Nginx up and running. Okay, the status has changed to running. If I connect to this, I should see Nginx. It is that easy to run a container on top of Fargate. As you can see, we have not deployed or provisioned any EC2 instance to be able to run that container in a brand new cluster. As you can see, we have one running cluster. How does this look like in the context of EKS? It's very similar. What I have here is a Kubernetes cluster that I have already previously deployed. This Kubernetes cluster is fairly empty. It only has a couple of pods running. They are the two core DNS pods that get deployed by default on an EKS cluster. If you look at the nodes that this cluster has, notice that it has a couple of nodes, and they are called Fargate IP something, which should give you a hint already. What I'm going to do now is I'm going to author a very simple, super simple deployment YAML file, Kubernetes YAML file, super standard. It's called my web, and it just runs Nginx, nothing more, nothing less. So if I kubectl apply this file here, oops, it says that my deployment has been created. If I look at the list of the pods, it shows pending. What it is doing is it's basically going out onto the Fargate fleet, sourcing a VM, connecting it to the cluster, and then run that container. That takes roughly 40, 50 seconds, maybe slightly more, depending on the size of the instance. But if I check back on the nodes momentarily, as you can see, there is a third node that is coming up. This is the node that has been made available into the EKS cluster for being able to run that my web deployment. As you can see here, there is no reference to platform version whatsoever, because this is basically hidden by the EKS platform. So EKS will use the features that are provided by a given platform version, but you won't get access to picking the platform version that you want to use in the context of EKS. Now that we went through the basic of what Fargate is, I wanted to get a little bit deeper into the new 1.4 version that we released when we released the new platform version. This is the list of features. I have a few slides for each of them with some demos as well. Obviously, each of these could be expanded. And what I usually have inside my presentation are links to either blog post or documentation that will allow you to get more details on the specific feature that you are interested in. Probably the most important one, certainly given the interest from customers that we have seen on our open source roadmap on GitHub, is the ability to be able to integrate with EFS. Historically, Fargate is and was until platform version 1.4 a platform to run stateless workloads. What this means is that each Fargate task or each task that runs on top of Fargate is stateless by nature, given the fact that the task only has access to ephemeral storage that lives on the VM that is powering that task. Also, historically, the way that you could run an ECS task on top of EFS was through some explicit configuration that you would need to do on the EC2 instance, so that EC2 instance would map the EFS endpoint, and then at that point the task that you would deploy on EC2 could connect to that EFS endpoint. It was a little bit more work on EC2. On Fargate, this was not even possible, given the fact that you could configure a Docker volume configuration inside your task, but that directive would require that your underlying host get access to it. Fargate wouldn't even allow you to get access to those EC2 instances, so you couldn't even do that. So what we have introduced with Fargate platform version 1.4 is the ability for any ECS task, actually. So this is an ECS feature that has been enabled inside platform version 1.4 for Fargate. We have enabled this new directive called EFS volume configuration. In this case, what this means is that the underlying infrastructure, both EC2 and Fargate, doesn't need to have an explicit configuration and connection into the EFS file system. It's all done underneath the cover by us, and what you only need to do is to define inside your task definition that you want to connect to a given volume. What this means is that you can create some sophisticated deployment. Think about deploying WordPress, for example, or an application that needs to scale out, like in this example, with multiple tasks, but each task needs to get access to a single file or a directory that needs to be shared. WordPress is a good example of this. Needs to be shared by all the tasks that you are running. If you are interested in getting more information about this, I wrote a blog series of 3 blog posts. You can see the link at the bottom of this slide. The link is for part 3, which is the practical example that you can use to set this up. Part 1 and part 2 talk more about the use cases and how this works. But there are links inside part 3 that allows you to read all these other parts. I wanted to show you how this works in real life. So I'm not going through the entire demo, but I just want to give you a hint about how this works. So I've previously created a file system. The file system on EFS is called up1, and I've configured this file system to be available in a number of availability zones through the creation of mount target in different subnets. The other thing that I've done is I have created what EFS refer to as access points. Access points are a construct that exists in EFS that allows customer to define application-specific entry point into the EFS file system, fundamentally making it easier to bypass the POSIX security mechanism and only use EM roles, for example, to get access to access points. For example, I have created this access point that point to this engineering files directory inside the file system. And this is what I want to connect with my task. So let's go back to the task that I created before the my app2 task definition in this case. What I could do is I could go back, create a new version or a new revision of this task and add a volume. Here, what we have done is we have added a volume type. Typically, you could use by mount, but in this case, the volume needs to exist on the host that provides the capacity for your task. What we have added is this EFS volume type. So if I give a name here, app1, for example, whatever that is, I can then pick my file system ID, app1, which is what we have seen in the previous screen, and I can also map a specific access point. In this case, engineering files. I want to enable transit encryption. I want to enable EM authorization, because basically what this does is it allows me to say, create an EM role that you associate to this specific task that can only read or can only read and write and not execute, for example, on that specific EFS access point. As I said before, these are the access point and file system that I have previously created here. Okay. Let's move to the new feature that we enable with platform version 1.4. Previously, the stack that we would provide as part of the Fargate virtual machine that we provision from the fleet would only have two local volumes, a 10 gigabyte volume for storing Docker images and a 4 gigabyte volume for mounts. This means that there is a wall between these two. So you couldn't use more than 10 gigabyte for Docker images, and you couldn't use more than 4 gigabyte for your own ephemeral storage usage, the ephemeral part that comes with the task. With platform version 1.4, we increased this and we removed that wall. Okay, so now every customer that starts their task with PV 1.4, they get 20 gigabyte of flat storage. You can use it for Docker images. You could use for your ephemeral storage needs. It's up to you. It's more flexible and it's bigger, essentially. This is, this comes out of the box. This is one of the features that you wouldn't need to opt in or whatsoever. It's just there. There are customers that were looking for more local storage. They would just restart their task, switching the platform version to 1.4, and they would get 6 more gigabytes of storage, essentially for free or included in the price of the Fargate task that they have been using. As a reminder, this storage is ephemeral. This has nothing to do with the EFS integration that we have seen in the previous slide. In the previous slide, we talked about being able to attach external storage, non-ephemeral external storage. So if your task gets life cycle, that task definition will keep connecting to the very same EFS endpoint or access point. In this case, as the task gets life cycle, this ephemeral storage just disappears. The next task will start with the same amount of ephemeral storage, but without the content of that. Another thing that is important to understand, and this is one of the reasons for which we basically keep on hold moving the flag, the latest flag from 1.3 to 1.4, is that we're changing with 1.4 some of the traffic flows for traffic in and out of your VPC, or actually your task. What you see in this is a number of different traffic flows. Obviously, at the very bottom, there is your application traffic, which doesn't change. But there are a few other traffic patterns, like, for example, how you source secrets from Secrets Manager, Systems Manager, and how you log into ECR, that have their path change with 1.4. This is probably better explained with the following slide. So you need to think about an ECS or a Fargate ECS task as having two different paths for external connectivity. There is what we refer to as a Fargate ENI, which lives in our managed VPC, and there is another ENI called the customer ENI or task ENI, as you have seen in the previous slide. We are changing some of the traffic that I alluded to, like ECR login, how to source Secrets Manager and Systems Manager parameter through the task ENI or the customer ENI. This is because lots of customers ask us to get more visibility in the traffic that those patterns would generate. Like, I want to be able to track, if the task is connecting to Secrets Manager and doing these sort of things. With the new traffic patterns that I just described for platform version 1.4, now pretty much everything happens inside the customer VPC through the task ENI or customer ENI. What this means is that you need to make sure that there is actually connectivity from your VPC to ECR or to Secrets Manager or through to Systems Manager. This could be because your VPC allows external traffic so that you can hit the public endpoints of those services, or it could be because you created private links inside your VPC. It doesn't matter. What matters is that you need to get that access to those services. So please test PV 1.4 if you have a similar setup to make sure that everything works as expected. The other thing that we have done with PV 1.4 is that we made the CloudWatch Container Insight experience a little bit better. This is probably better shown in a live demo than on a slide. So what I'm going to do is I'm going to show you CloudWatch Container Insight. For those of you that are not familiar with Container Insight is a new product inside the CloudWatch family that allows you to check and track metrics for containers, both for ECS as well as EKS, in addition to logs. So if I pick, for example, ECS tasks, and I pick my cluster, for reference, my cluster is that cluster that had 2 running tasks. I want to show you this before. So if I examine this task, I have two running tasks. One is coming from a task definition that I called Nginx 13, and another one comes from a task definition called Nginx 14. I did create two task definitions because I wanted to make it a little bit easier to relate to the platform version that I'm running them on. And Nginx 13 runs on Fargate platform version 1.3. Nginx 14 runs on Fargate platform version 1.4. If I go back to CloudWatch and specifically the ECS task pointing to my cluster, you see here that I'm running or I'm tracking Nginx 13 and 14. What you see here, and the difference that you see here, is that while for CPU, memory, and storage, I do have both Nginx and 13 and 14, for network traffic, I only have Nginx 14. This is because up until platform version 1.4, Container Insight was not able to track network statistics for Fargate task running on any platform version that was before 1.4. So customers were looking for a way to being able to monitor their Fargate task across the board of all the subsystems, CPU, memory, disk, and storage. And platform version 1.4 gives customers that full visibility on all those four subsystem dimension. The other thing that we have done with starting from platform version 1.4 is that we allowed CSP Trays. CSP Trays is a Linux capability that is typically enabled on traditional EC2 instances, or you can use inside tasks that runs on the EC2 instances, but that has been historically disabled for Fargate task or task that runs on the Fargate fleet. There are, however, certain customers that care a lot about being able to meet some compliance requirement. There are lots of regulated industry that requires this deep instrumentation that allows customers to be able to track and observe running processes inside those containers. So malicious access to files, opening files or opening network connections. You want to be able to trace them and report them as an anti-pattern for your application, for example. So what we have done in collaboration with some of the partners like SysDig, for example, in this slide, and you see a link at the bottom of this slide that is a blog post that SysDig released a few days after the release of PV 1.4, where they are discussing how Fileco, their open source project, will allow connectivity and integration inside Fargate platform version 1.4 so that they will be able to track all of those patterns and anti-patterns for your containers. As I said, this is very useful for customers that have regulatory requirement to be able to demonstrate from a compliance perspective that the container behaves in a particular manner. Similarly to how we describe new features that were made available for Container Insight to be able to track network statistics, we have done a similar thing through task metadata. So starting from PV 1.4, we now allow customers and partners that deploy sidecars inside and alongside their application in the same task to also read network stats inside Task Metadata v4. Task Metadata v4 is a new version of Task Metadata that we released with PV 1.4. And in addition to allow to customers and partners to grab stats for CPU, memory, and disk, now Task Metadata v4 allows you to read network statistics in addition to CPU, memory, and disk. In addition to this, Metadata v4 allows you to track which AZ your task has been deployed to. Because remember, there is no infrastructure, so you cannot pick an EC2 instance based on the availability zone where that instance is in. When you deploy a task, we pick an availability zone to deploy that task. And through Task Metadata v4, now you have an insight in terms of which AZ your task has been deployed to. Going back to the network stats that I was alluding to before in Task Metadata v4, Datadog, one of our partners, have leveraged this feature. You can read more at the link in the blog at the bottom of this slide, where they said that they have improved their Datadog agent when running alongside a container in a Fargate task to be able to track network statistics in addition to CPU, memory, and disk. So this is an example where a partner has been developing or extending their own technology to take advantage for the end customer of feature that we released. Last but not least, in this slide, we're going to talk about the radical change that we have done with platform version 1.4. This is not, strictly speaking, a customer visible feature per se, but it's one of the reasons for which we wanted to bundle all these changes into a new platform version. Previously, before 1.4, the stack that comprised our platform version would include Docker Engine and the ECS agent. Docker Engine was the container runtime that we were using to start your containers, and the ECS agent was the agent that we would use to connect to the orchestrator ECS historically. What we have done with platform version 1.4 is we changed these two pieces. We introduced containerd instead of Docker. And also the other thing that we have done is we changed the ECS agent with a brand new dedicated Fargate agent. This also speaks to the fact that Fargate has become container agnostic, meaning that you can use it both in the context of ECS as well as EKS. If you want to go deeper into this behind the curtain type of information about how we build a new platform version, there is a link to a deep dive blog post that one of our engineers has written when we announced platform version 1.4. I suggest you to read that blog post. As a recap, what have you seen in this session? In this session, we went through the basic of Fargate and we described it as a serverless platform to run containers. Obviously, as I said and have demonstrated at the beginning, this is available to both ECS and EKS. This is a key point to keep in mind, that Fargate is container orchestrator agnostic at this point. Fargate uses the notion of platform version specifically in the context of ECS, as we have seen throughout the presentation. And the reason for which platform versions exist in the first place is to mitigate the risk for customers to move from entirely different stacks that may have different OS version and container runtime version that may drift the behavior of their application. And as we discussed, obviously Fargate platform version 1.4 introduced a big number of new features. We went through all of them in this presentation. Probably the most important, but at this point it comes down to personal preference, is the EFS integration. And the reason for which I like this feature is because this unlocks and unblocks a lot of customers that were looking the simplicity of running containers on Fargate, but had the requirement of having to run stateful workloads. Previously, before 1.4, the only workload that you could run on Fargate were ephemeral workloads. With this being said, we're done with this session. Thank you very much for sticking around, and thank you very much for watching this. If there is anything that I can help with, going a little bit deeper into some of this information, please reach out to me. As you can see here, there is my email address, Twitter handle, GitHub account. Feel free to reach out, ask me questions, and let's keep in touch. Thanks again for watching. Bye-bye.